So standard form of combining functions says when a polynomial is ordered from the variable with the highest exponent down to the lowest. So that's how we write it in standard form. So we start with the highest exponent all the way down to the lowest. So the highest exponent in this one is x to the fourth. We're going to say x to the fourth minus x to the third plus x. Here it would be a to the third. So 3a to the third plus 5a squared plus 1. Here the highest exponent would be 12x to the fourth. And then just plus 3. So you start with the highest exponent and work your way down. Now in example 4, it's kind of a trick problem. Okay, all three of them in example 4 have x to the third power. So you actually can reduce example 4 into just one thing. So 7x to the third minus 10x to the third, that's 7 minus 10, that's negative 3, plus 1x to the third, that's negative 2. So it really should just be negative 2x to the third. So you're able to just reduce that into one term, one thing. Which goes to our next thing, which says the number of terms. In example 1, you have 3 terms. Means 3 different things. A term is separated by adding or subtracting. So there's 3 terms in example 1. There's 3 terms in example 2. There's 2 terms there. And there's only one term, negative 2x to the third, in example 4, because we were able to combine all those together. Next, we look at the degree. If you look at the top, we've defined what the degree of a polynomial is. The degree of a polynomial is the highest exponent of a function when it is in standard form. So the biggest degree in this one is 4. The highest degree in this one is 3. In this one, it's 4. And again, in this one, it is 3. Now, I also want to give you a name for these if it is to the 4th degree. So if it is x to the 1st degree, so just an x, it would be a linear function. If it's x squared, it would be quadratic. X to the 3rd, if it's to the 3rd power, we call that a cubic. So both of these are cubic because their highest degree is 3. X to the 4th would be to the 4th power. That is called quartic, like a quarter. So quartic, because there's 4. So that's about as far as you need to know as far as like the powers that they go to. So x would be linear, x squared would be quadratic, x to the 3rd would be cubic, x to the 4th would be quartic. On your calculator, if you went to stat calc, it actually would go in that order on there. If you go to stat and go over to calc, it goes linear, quadratic, cubic, quartic. It shows you those if you forget the order that they go in. Now, we also want to talk about the name of the polynomial. So it's 3 terms and to the 4th degree. That makes it a quartic trinomial. So remember, if it has 3 terms, we call it a trinomial. If it has 2 terms, it's a binomial. If it has 1 term, it's a monomial. So this is a cubic trinomial. Then we get a quartic binomial. Then we get a cubic monomial. So all of those come from, so that should be like the number of terms. You only have to learn monomial is 1, binomial is 2, trinomial is 3. If it's anything bigger than 3, we just call it a polynomial, okay? Because poly means many, so it's just more than 3. If you have a degree that goes over 4, we just say to the 5th degree or to the 6th degree. We don't keep going higher than that. 1st degree is linear, 2nd degree is quadratic, 3rd is cubic, 4th is quartic. So that's how we name a polynomial. You can name them. You can name a polynomial by degree, So the highest exponent, and you can name a polynomial by the number of terms. And if it asks you to put it in standard form, then it wants the highest degree first, and you're basically going from the highest to the lowest. What type of function will be created when you combine the following functions in the manner listed? So in the second table, or in the third column there, you want to say what's your hypothesis? This is a guess. It doesn't have to be right. What function will be created when you do this? So in the first one, it says when you add two linear functions together, you will create a what? When you multiply two linear functions together, you will create a what? When you add a linear and a quadratic together, you will create what? When you multiply a linear and a quadratic together, you will create what? When you subtract a linear from a quadratic, you will create what? And when you divide a cubic by a linear, what will you create? So what type of function will you create? So the answers to those would be linear, quadratic, cubic. What type of function will be created when you do those things? So I'm going to let you guess. Put in your hypothesis in the third column. Go and solve those. So when you add two linear functions together, think about, we're going to combine like terms. So x plus x is going to give us 2x, and 1 plus negative 3 is going to give us minus 2. That's still a linear function. Okay? So it's a linear function because it just goes to x. When you multiply two linear functions together, you're thinking about using the box method or FOIL. So you have to do x times x, that gives you x squared. You have to do x times negative 3, that gives you negative 3x. 1 times x gives you positive 1x, so you have to add those together, that's negative 2x. And then 1 times negative 3 is negative 3. So that is a quadratic function. So if you multiply a linear times a linear, you get a quadratic. If you add a linear and a quadratic together, so x plus x squared, well, you can't add things, you can only combine like terms. So you're going to end up with x squared plus x, and then 1 plus 3 is 4. So that still gives you a quadratic function. Okay, in D, if you multiply a linear and a quadratic, now you're doing the box method or FOIL. X times x squared gives you x to the third. X times, we can do the inner. 1 times x squared gives you x squared. X times 3 gives you 3x. And then 1 times 3 gives you 3. So that goes to the third power, so that is a cubic function. So multiplying, you notice that your exponents are going up, your powers are increasing. Subtracting a linear function from a quadratic. Well, again, you can't combine, you can only combine like terms. So x squared minus x. And then here you have 3 minus a positive 1, so that is 2. Okay, so that is still a quadratic function. And then lastly, if you divide a cubic by a linear, that's dividing, those are your exponent rules that we did a long time ago. So x to the third over x to the first, 3 minus 2 gives you x squared. You end up with a quadratic function. If you divide a cubic function by a linear function, you end up with a quadratic function. So they're just showing you some of the different things that happen here. So if we look at this, if we look at our conclusions and kind of what happens, when you add functions together, when you add or subtract, so you look at A, C, and E. If you take a quadratic and you subtract something, you still end up with a quadratic. In C, if you take a linear and a quadratic and you add, you still end up with a quadratic. In A, if you take two linears and you add, you still end up with a linear. So you're not changing the function. But in B and D and F, when you multiply two linear functions together, you do get to change the exponent, so it changes to a quadratic. In D, when you multiply a linear and a quadratic, it changes to a cubic. And in F, when you divide the exponents you're subtracting, so it changes it from a cubic now to a quadratic. So the goal to know, basically, what you need to know from that is when you're adding and subtracting, your exponents aren't changing, but when you're multiplying and dividing, your exponents can definitely change, which means the function can change. So we're going to do all four. We're going to be adding, subtracting, multiplying, and dividing today. Quadratic. So if we take a cubic and divide it by a quadratic, 3 minus 2 will give us just x, and that gives us a linear function. So when we divide a cubic by a quadratic, again, we're subtracting our exponents, so that just gives us x to the first power, just x. So it is a linear function for g. Okay. Now, when combining functions, you may see all of these things. So adding f of x plus g of x, it may look like that, or they may say f plus g of x. It means the same thing. F of x minus g of x, or that. F of x times g of x, f of x divided by g of x. Both of those mean the same thing, so it's just showing you two different ways they can write it. All right. If you look down here, we have f of x, g of x, h of x, m of x, n of x, and p of x. And we want to do all kinds of different things. We're going to add, subtract, all that. So first, it says f of x plus g of x. So f of x is negative x plus 4, and g of x is x minus 1. And we want to add those together, combine like terms. Here, f of x minus h of x is negative x plus 4, minus h of x is x plus 5. Again, we're going to want to combine like terms. We'll go back to these in a second. And then f of x, again, is negative x plus 4, plus p of x is 3x plus 1. So in the first three, all we're doing is adding or subtracting. So we're just combining like terms. We're going through and adding. You got to be careful with the subtracting too. But we're going through and adding negative x plus positive x means the x's are now gone in those because you have negative 1x plus 1x. So you get 4 plus negative 1, that gives you 3. So our answer is just 3 there in the first one. F of x minus h of x. We have negative x minus x. That gives us negative 2x. Okay? And 4 minus a positive 5 gives us negative 1. So you better be careful with the subtraction ones. Okay? I'd be very careful with that. In number 3, negative x plus 3x gives us a positive 2x, and 4 plus positive 1 gives us a positive 5. So we end up with 2x plus 5. If you see in those we had linear functions and we were adding them or subtracting them together, we end up with linear functions, except in number 1 because the x's went away. So that's 1, 2, and 3. Anybody got a question on those? Just adding and subtracting, combining like terms right now. Okay, and move forward. So if we move down on here to the next couple questions, we're going to continue using those same equations in example 6, but we're going to go down in 4, 5, and 6, and then 7, 8, and 9, and try to answer these. So in 4, 5, and 6, we are adding in all 3 of these. So we want to write down what it is we're adding, and then I'm going to give you a chance to go through and do that. So we're adding these like terms. So in number 4, g of x plus h of x. So again, this is x minus 1 plus, and then h of x is x plus 5. Number 5, m of x plus g of x. M is x squared plus 2x plus 1 plus g of x is x minus 1. And number 6, n plus m, so 3x to the third minus 3x squared plus 3x minus 1 plus x squared plus 2x plus 1. And we want to combine like terms. Remember, that's all we can do when we're adding and subtracting is combine like terms. And combine like terms, so we add our x's together. So we're going to get 2x. Negative 1 plus 5 is a positive 4. Over here, x squared, we're going to have to leave it. Then we have 2x plus x. That's going to give us 3x. We have positive 1 plus negative 1. Those will go away. Over here, 3x to the third. Then we have negative 3x squared plus a positive x squared. That's negative 2x squared. We have 3x plus a positive 2x. That's 5x. And we have negative 1 plus a positive 1. That means that will go away. So there's where our answers come for 4, 5, and 6. So we get 2x plus 4. We get x squared plus 3x. And then we get 3x to the third minus 2x squared plus 5x. And now we're going to move down to 7, 8, and 9. So in question number 7, you are subtracting m of x minus g of x. So we're going to say x squared plus 2x plus 1 minus g of x, which is x minus 1. Here we're going to multiply f of x times g of x. It's negative x plus 4 times x minus 1. And then here we're going to multiply g of x times m of x. So x minus 1 times x squared plus 2x plus 1. Okay, so each of these three, we're doing something different. So again, you have two ways to approach number 7. Make sure that you see this as, you have to read this as minus negative 1. You could change this to addition if you want to change everything that comes after it, but you don't have to change it to addition. But if you do, you have to change every sign that comes after it. So the x squared stays there. We have 2x minus x, that leaves us with 1x. And we have 1 minus negative 1, that leaves us with a positive 2. A lot of people miss that. You have to read the sign as it goes. 1 minus negative 1. In 8, this is FOIL, or the box method. So we have negative x, 4. We have x and negative 1. So we're going to have to multiply a binomial times a binomial. So that's negative x squared. 4 times x is positive 4x. Negative x times negative 1 is a positive x. And 4 times negative 1 is negative 4. And then we can combine like terms, which is our 4x and our positive x. So we get negative x squared plus 5x minus 4. And then finally in number 9, which is multiplication, it's the box method. Also, it's just we got 6 boxes instead of 4. So we are going to combine into all 3. So we have x squared, 2x, and 1. And we have x and negative 1. So x times x squared is x to the third. X times 2x is 2x squared. And x times 1 is just x. So we got that one. Negative 1 times x squared is negative x squared. Negative 1 times 2x is negative 2x. And negative 1 times 1 is negative 1. So we've got all our things there. If you look at the diagonals, that's always what you're going to be combining. That's where you combine your like terms in the diagonals. So you have x to the third. Your first diagonal is right here. Negative x squared plus 2x squared. That gives you 1x squared. Then we have x plus negative 2x. That gives you 1 plus negative 2. That's negative 1x. And then minus 1. And so you have your final answer there. So again, That's where it gets to about the hardest you can do is where you have to go through and combine like terms after you have multiplied. So that's where we're asking you to multiply, but then add and subtract at the end to combine the like terms in the function. So that's why this first section is just called combining functions. You're going to add, subtract, multiply, and divide in order to combine. Where it says to use division and to simplify, this would be it can be very simple. So using division to simplify, I'll take a problem like let's take one like number 37. Okay, so if you take number 37, you see 20x to the fourth plus 15x squared over 5x squared. You look at all three terms and you say, what can I divide out of? What do they all have in common? What can I get rid of from all of them? 20, 15, and 5 will all go to 5. So I can get rid of the 5. And then all of these at least have x squared. So they at least have x and x. So I'm going to divide by 5x squared is what I'm getting rid of. And you see that's why that's at the bottom. So basically what I'm doing is I'm taking 20x to the fourth and dividing it by 5x squared. And then I'm taking 15x squared and dividing it by 5x squared. So I want to make sure that you see that these are really, it's basically like there's two fractions there. Like number 36 would basically be like there's three fractions. So 20 divided by 5 is 4. And then x to the fourth over x squared, you subtract your exponents. So it's x squared. So 4x squared plus 15 divided by 5 is 3. And then x squared over x squared, they go away. So you have 4x squared plus 3 as your final answer in 37. So they don't have to be, they're not very difficult when you're dividing. I just wanted to show you an example of that so that you can see exactly what's happening. You can split them up into separate fractions, and then that way you'll get your final answer when you divide that number out of each of them. So that's the goal there. Monomial means it has an x, monomial means it's one term. Binomial means we got two terms. Trinomial means we got three terms. Polynomial means more than three terms. And then a constant is just a number. Okay? Just a number. No x's at all would be a constant. Then part 2 says standard form. We want the problems to be in standard form. Remember, standard form means the highest degree to the lowest degree. Then it asks you about one of those problems. Then we start our adding of polynomials. Then we start our subtracting of polynomials. We start our multiplying of polynomials. And finally, our dividing of polynomials, like I went over there. So we're going to go through each of the 4 steps, and you have problems on each one. And then you're done with combining polynomials, which hopefully will seem like an easy unit to start. An easy lesson to start, Unit 6, Polynomials.